Okay, so today we have an important class. We are going for reading some of the scheduling algorithms. Some of the problems also we'll solve. Just before that, let me tell that what we have discussed in the previous class. We have discussed about the CPU scheduler. CPU scheduler is responsible for selecting a process from the ready queue and give the control to the to the CPU with the help of dispatcher. There are two different kinds of scheduling we have read. One is preemptive, another is called the non-preemptive scheduling. This is important. Preemptive and non-preemptive. The preemptive scheduling, which are called the preemptive scheduling. Suppose in a scheduling, the CPU is assigned with a process, and in the middle of the execution, during the execution, the processor can release the process. Then we said it's a preemptive. The process can be preempted. So once the CPU can release the process even in the middle of the execution. But what is non-preemptive? Non-preemptive says that the process cannot be. Voice is not audible. Okay, is my voice clear? Is it audible?
Yes, sir, it is audible.
Okay.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So non-preemptive scheduling says that once the process is assigned to the CPU will not release the process unless it is being completed or going to the waiting state. Correct? Non-preemptive, that means it will not be preempted. Process cannot be preempted unless it is not being finished. It will not preempt it. Preempt means during execution it can be preempt. It can be taken out. Suppose one process is running, another higher priority process will come, then it can be preempt. Correct? And we have learned about the dispatcher, which is a module connects the process that is selected by the short-term scheduler or CPU scheduler to the processor. So this is a module which will connect these two. And the amount of time it takes to stop one process and to start another process, that latency is known as the dispatch latency. This is also a short question. Dispatch latency, difference between non-preemptive and preemptive scheduling. Now we'll go for some scheduling criteria. Why we'll go for this scheduling? Why you are selecting a particular process? Based on what things will be selecting a particular process? Because there are many processes are there in the ready queue. I am selecting a process. The CPU scheduler is selecting a process and giving it to the CPU. Based on which criteria it will select? It says that there are some criteria, scheduling criteria. This also comes as a sometimes as a medium length question, that what are the different scheduling criteria are there? These are the different scheduling criteria. The first one is CPU utilization. We need to keep the CPU as busy as possible, preferably between 40 to 90%. What do you want? The CPU, most of the time CPU should be busy. So that means the CPU scheduler or the short-term scheduler has to select the processes in a particular order so that always CPU will be busy. So there must be an intervention between the CPU bound process and IO bound process. So most of the time CPU must be busy in doing the work. So what is the order in the processes must be selected. The next one is throughput. Throughput says the number of processes that can complete their execution per unit time. How many processes can complete in a unit time? So more throughput means more processes can complete. So scheduling must be done so that more number of processes can be completed per unit time. Correct? Throughput means number of tasks completed per unit time. So you want more throughput. Turnaround time. Turnaround time is the time difference between the completion and arrival time. Suppose the time difference between the completion and arrival. Suppose the process arrives at 9:15, completes at 9:30. So 9:30 minus 9:15 is the turnaround time. Is it understood? The turnaround time is the amount of time to execute a particular process, which is the difference of completion and submission. At a particular time, a process is submitted, and after some time, the process is completed. The time difference between that is the turnaround time. Is it understood, anyone? Anyone having doubt? Turnaround time, the total time taken between the submission and the completion, right? So, so turnaround time should be minimum or it should be more, maximum? Turnaround time minimum. Very good. So now we'll go for the next one, is the waiting time. Waiting time is the amount of time a process has been waiting in the ready queue. Amount of time a process has been waiting in the ready queue. So during the execution, sometimes it may have to come back again to the ready queue. So it will wait over there, again the processor will address it, correct? Suppose the processor is started execution. It will execute for some time, it will again go come to the ready queue. Suppose any IO occur, it will come to the ready queue. Then after ready queue, it will again go to the processor. So this is going on. How much time the process has spent on the ready queue is the waiting time. In that time, the process is only waiting. Is it understood what is waiting time? Waiting time means during execution, not all the time, not all the turnaround time is used for execution. Some of the time it is being executing, rest of the time it is only waiting. Correct? So waiting time is turnaround time minus burst time. Burst time means execution time. Burst time means this is execution time. Right? So total time taken minus the amount of time it has executed, rest of the time it is just waiting. Is that understood? Anybody having doubt on waiting time? Is there any doubt on waiting time? The total time minus execution time, turnaround time minus burst time. The next one is hello.
What is the brush time?
Burst time is the amount of time the process takes for execution. That is execution time. Burst time means execution time. Burst time means execution time. Correct? Okay. Any other doubt? Okay. Now response time is the amount of time it takes from when a request was submitted until the first response is produced. So response time is not when it is being completed. Response time is the time difference between the what time the process request is submitted, what time the request is submitted until the first response is produced. So it is not considering that when it will output, not the output, or when it is completing. How much time it has taken for first response, that is the response time. So response time has to be minimum or maximum? The response time has to be minimum or maximum?
Minimum.
Minimum.
Waiting time? Waiting time?
Minimum.
So, okay, we want waiting time to be minimum, turnaround time to be minimum, and response time to be minimum. Can you differentiate between these three or not? Turnaround time, waiting time, and response time. For example, I take an example of a hospital. A patient is admitted. The patient comes into the hospital. It is not that the patient, the moment it comes, the doctor will be busy in working on that patient. The moment the patient is admitted, there are some processes. It will be registered, and then some work has to be done. Then the doctor will come to attend. And after that, let the patient is there in the hospital for 4 hours. Do you think that all these 4 hours the doctor is busy in attending that particular patient only? So doctor is attending
Yes,
sometime,
sir.
in doctor is attending sometime, then it is going for some other patient, then again it will come back and attend that patient. So the sum of all the time the doctor is actually attending the process is the execution time or brush time. Try to understand. The actual time, the amount of sum of all the amount time, all the time which the doctor has actually attended the patient. But what is the turnaround time? Turnaround time is the time the patient is just entered into the hospital till the patient is released. The entire time is the turnaround time. What is the response time? When the patient first initially arrived at the hospital, how much time it has taken for a doctor to first respond, because there are many things has to be done, then the doctor will respond, the doctor will come. So what is the amount of time for that patient to attend the first attended by the doctor? So this doesn't include the waiting time and other thing. When it is first being responded, that is the response time. So we want less response time, less waiting time, less turnaround time, whereas we need maximum CPU utilization and throughput. Correct? The system should always try to maximize the CPU utilization and throughput and minimize the turnaround time, waiting time and response time. Right? So you can see over here the scheduling criteria says to maximize the CPU utilization and throughput, whereas to minimize these three. To minimize the turnaround, waiting time and response time. Correct? So this is our scheduling criteria. We want to do this. We want this minimization of these three and maximization of these two. So therefore, what is the order in which how the processes should be selected so that this criteria can be achieved? So for this, many different scheduling algorithms are being proposed. Many different CPU scheduling algorithms are being proposed. So those are like fast come fast serve, you have priority scheduling, shortest job first, shortest remaining time, round robin, multi-level queue. You have different scheduling algorithms, CPU scheduling algorithms are there. So some of the CPU scheduling algorithms will learn over here. We'll do some problems on the CPU scheduling algorithm as well. Correct? So what is the objective of this CPU scheduling algorithm? Is to maximize these two CPU utilization and throughput and to minimize the turnaround time, waiting time and response time. So is it understood? So there are some useful facts about the scheduling algorithm. Although I will repeat it again, but till I'll let them, I'll clarify it before that. One of the algorithm is fast come fast serve, that will read first. Fast come fast serve can cause long waiting time. So these are actually outcome of the different algorithms. So I am just skipping this part only. I will discuss it later, that each algorithm has some problem or advantages over there. So this is being summarized over here. So that I will discuss later. But during our scheduling algorithm problem, we will be using a chart called the Gantt chart. Gantt chart is being used, is a useful graphical tool which shows the activity of tasks performed against the time. So we'll have actually it is a time graph, in what time which process is executing, that is being represented through a chart, and that chart is known as the Gantt chart. Correct? So what is a Gantt chart? It says what time which process is executing. That means the process is, what is the sequence of execution, each process is executing for how much time. So that is being represented in a chart, and that chart is known as the Gantt chart. We'll be using in our subsequent algorithms. So I said that these things I will discuss the first 4 points, but these will be discussed after going through all these algorithms so that you could able to understand. So coming to the fast scheduling algorithm is the fast come fast serve scheduling. Is the simplest algorithm. Fast come fast serve algorithm, FCFS algorithm. Correct? So a problem will be given, and it will be given that to compute the response time or turnaround time or waiting time, if a fast come fast serve scheduling is being used. So let us discuss what is this fast come fast serve. The process that requests the CPU first is allotted the CPU first. What it says, whichever process is coming fast and requesting the CPU is allocated to that process. For implementation of FCFS, we use the FIFO queue, first in first out. We use a queue over here. And when a process enters a ready queue, its PCB is linked to the tail of the queue. So always it is added at the end of the queue, like it is being there in a queue, FIFO queue. Insert at the rear end and delete from the front end. So when the CPU becomes free, it is allocated to the head of the queue and the process is removed from the queue. So when CPU idle, that means it will take a process. From where it will take from the head of the queue. Delete from the head, insert from the rear end. The average waiting time of FCFS scheduling is quite long. This line you must remember. The average waiting time of FCFS scheduling is quite long, right? FCFS is non-preemptive. FCFS is non-preemptive. Do you know what is non-preemptive means? I have already told. FCFS means once the processor is assigned with a process in a FCFS manner, suppose it is being selected and is given to the CPU, CPU will keep on executing that process and will not release until it is not being finished or it is not being terminated. So FCFS is non-preemptive because once the CPU is allocated to a process, that process keeps the CPU until it releases the CPU either by terminating or by requesting an IO. Correct? So this is the FCFS. This is about the FCFS scheduling. Just think of you are going to a photocopy shop, the Xerox shop, and you are having some papers to be Xerox or to be photocopied, and there are some people are standing over there. What is the order in which the person will make the photocopy? One of the rule he can make that fast come fast serve. Suppose somebody has arrived first, he will be served first, right? If two people, suppose while opening the shop, he found two people who are standing over there. So both are same now, both are arrived at the same time. So anyone can be selected. Any one of them can be selected as the first person. Then it will go on serving the people the order in which they will appear. Correct? Just think of the first person is having to photocopy a book which is of 500 pages. 500 pages. First person who came has to Xerox 500 pages. So he is at the front of the queue, right? Now the shopkeeper will just take his work and start doing, because it's using the FCFS. Unless the first one is not finished, he cannot go for the second one. Just think of the second person who is standing over there might have only 1 page or 2 pages to be Xeroxed, 2 pages only to be photocopied. He has to wait for a long time, right? The response time is very large and waiting time is also very large. Correct? So if you will start serving the first one, which is having 500 pages, there might be a chance that many of the people, many of the persons who are coming with short burst time or short execution time, they are just waiting for a long time, right? So just look over here. We'll take an example. Suppose that the system receives the following processes: P1, P2, P3 with burst time of 2433. Do remember what is burst time? Burst time is the execution time. Let me write over here so that otherwise you will be confused. This burst time is nothing but the execution time. Correct? Now see how. So brush time is, what is brush time is called? Brush time is called the execution time. Right? So now see here, which of the following two arrival orders is better? Now it says that if I go for executing 2433, let me execute over here. If I draw the Gantt chart over here, suppose P1, P2, P3. Arrival time is not given, so we will assume that P1 comes first, then P2, then P3. Correct? This is the Gantt chart over here. The Gantt chart says what? The how much time a particular process and what is the order in which they are executing. Suppose P1 comes first. So P1 will execute from time 0 to time 24, because 24 is the execution time for P1. Is it correct? Now then when P1, as it is a non-preemptive, so if P1 is assigned, we cannot take out P1. P1 will be there till its end. So all the 24 second unit of time it will take, maybe millisecond, nanosecond, whatever it is, the 24 amount of time it will take. Then P2 will come, P2 for 3 seconds, right? So 24 to 27 is the P2. And P3 is for the next 3 seconds, so 27 to 30. Correct? So what is the total time taken for while executing all these three? For all these three, it is from 0 to 30. 0 to 30. Correct? Can you tell me how much time the P1 waited over here? Anyone who can say how much time P1 is waiting? Who can say how much time P1 is waiting over here?
0.
0. Very good. How much time P2 is waiting?
3.
20?
24.
24. And P3 is waiting for?
27.
27. So what is the total waiting time? Total waiting time is 0 plus 24 plus 27. Is it understood? So waiting time for P1 is 0, for P2 it is 24, for P3 is 27. So what is the average waiting time? Average waiting time is 0 plus 24 plus 27 by 3. It is 17. Correct? Is it understood or not?
Yes,
So,
sir.
okay. This is, we have computed which one? We have computed the waiting time. If it is there to compute the turnaround time, can you compute the turnaround time? We have a formula over here. We have read turnaround time formula. We have read. What is turnaround time? Turnaround time is completion time minus arrival time. Completion time minus arrival time, or you can do one thing, execution time plus waiting time. That can also be. Turnaround time can be execution time plus waiting time. It can be. It can be. The same will come. Is execution time or brush time plus waiting time, the total time over here. Correct? Now what is the time it will take? Now what is the time it will take over here? See, what is the time it will take over here for turnaround time? Can anyone say? For P1, what is the turnaround time?
24.
24. For
24.
Yes. For P2, it is 24. Yes. Hello.
27.
Hello. Not here. Okay. So execution time plus the brush time. So 24 plus 3, 27. And for 3, it is 27 plus 3, 30. So if it is there to find the average turnaround time, what you will do? You will sum of all the turnaround time and divide by 3. Correct? Now just think of the same problem. I am just changing the arrival order. Suppose P2, P3, P1. First P2 has arrived, then P3, then P1. Can you draw the Gantt chart for now? First P2. If first P2 will come, then it is from 0 to 3, because for P2, the execution time is 3. The next P3 is 3 seconds. So from P3 is from 3 to 6. Then P1 is from 24, is for 24 seconds, from 6 to 30. Is it understood? Is the Gantt chart for the second one is understood or not? Okay. So now compute the average waiting time and average waiting time over here. So waiting time for P2 is 0. Waiting time for P3 is 3. Waiting time for P1 is 6. So for P1 it is 6. For P2 it is 0. For P3 it is 3. So average waiting time is how much? 3. But whereas in the previous case, the average waiting time was 17. Can you see the difference over here? Why the difference is there? Why there is so less average waiting time in the second case, whereas the average waiting time is very high in the first case? This is because the P1, which is having a higher burst before a short processes or short execution time processes are there. So therefore, the processes having shorter burst time are waiting till the higher burst time has not been finished. Okay. So if all three processes come at same time, then which picked first by the CPU? Just this is one query. Just look over here. The example that I have given over here, assuming that all arrived at the same time. See over here, P1, P2, P3. Have I given the arrival time? I have not given the arrival time. This means all arrived at the same. So we can take any order. And if in the question, if it is given like this, you just solve it the order in which it is being written. Suppose P1, P2, P3 I have written in this order, you can solve in this P1, P2, P3. But if all arrived at the same time, then a processor can choose any one of them. Correct? Here the arrival time is not given. But in the question, the arrival time must be given. I will go for another problem over here. So we have seen over here the second arrival is better, right? But we'll go for one more problem. Here the arrival time is given. Let's see that how to solve it. I'll P0, P1, P2, P3. I'll solve it over here. P0, P1, P2, P3, process, and what is given? Arrival time 0, 1, 2, 3. The arrival time is 0, 1, 2, 3. This is arrival time 0, 1, 2, 3. The arrival time, and the burst time is also given. The burst time is 5386. 5386. 5386. Is that clear? This is. Can you see the Excel screen or not? Can you see it?
Yes, sir.
Okay. So
Yes, sir.
okay. I'm just okay. This is process, this is arrival time, and this is burst time. Okay, this is given. I want to compute the waiting time. I want to compute the waiting time over here. I want to compute the waiting time. Just think over here. This is the Gantt chart we will draw. Suppose this is the Gantt chart we will draw. We'll draw it. Okay. So now, this is for process P1. So which will come first? First you tell me who will come first. Out of this, this is given. Who will be served first?
P0.
P0.
Because arrival time is 0. Because arrival time is 0. Correct? It is not because it is written first. Look into this arrival time. Whoever have arrival time less, that is arrival time 0 over here, I will take P0. So the P0 is so a P0 is from which time to which time?
2 5.
0 to 5. Very good. Next, which one will come?
P1.
Then P1 will come. The P1 is from 5 to
5 to 8.
5 to 8. 5 to 8. Oh, it's in. Okay. So next one, then it is P2. P0, P1, P2. The P2 is from what? 8 to 8 to what?
16.
8 to 16.
16.
8 to 16. And eight to 16. Then P1, P2, then P3 will come. The P3 will come, that is from 16 to how much?
22.
22. Correct. So now we see. Now we'll compute the waiting time. Now we'll compute the waiting time. What is my waiting time for P0?
0.
0. Very good. This is 0. This is 0. What is waiting time for P1? P1 is
5.
see over here, just a second. P1 is getting at what time? 5. But it has arrived at 1. So actually, how much time it is waiting? Try to understand. P1 got at 5. P1 got its chance at 5. But it has arrived at 1 time clock 1. That means it is waiting actually for 4 seconds. Is it understood or anybody having doubt?
Can you explain one more time?
Suppose. In previous case, arrival time, in the previous example, arrival time was not given. So assuming that all is arriving at 0 time. Here, the P1 has arrived at 1 second, but he got the chance at 5 seconds. So how much time actually he is waiting? He is waiting 5 minus 1. Suppose in that example, Xerox shop example that I have given, the first person who came is he has 5 pages to Xerox. He is coming at 0 time. After 1 second, the second person come, but he has to Xerox only 3 pages, but he got chance at 5 seconds. So after 1 second he has arrived, he got the chance at 5 seconds. That means how much second he has actually waiting? Is 5 minus 1. Is it understood?
Yes, sir.
So similarly, can you tell me for how much time the P2 is actually waiting?
6 seconds.
6 seconds.
P2 got at 8, correct? But he has arrived after 2 seconds. So he is actually waiting for 6 seconds. Correct? Similarly for P3, P3 got the chance as 16, but he has arrived at 3. So therefore he is waiting for 13 seconds. Is it understood or any doubt? Is it understood? So what is the average waiting time?
Yes, sir.
So average waiting time is 0 plus 4. So 4 plus 6 plus 13 divided by what? Divided by 4.
4.
Okay. So average waiting time is 5.75. If it is turnaround time is given, suppose turnaround time is given. Can you tell me what is the turnaround time for P0? Very simple. Turnaround time is the browse time plus waiting time.
5.
Browse time plus waiting
5.
time. Yes. So browse time plus waiting time is turnaround time. Oh, this is not a formula, sorry. So again, this one is how much? I'm just writing 4 and 6 over here. 4, here I'm writing 6, here it is 13. Okay, so now I'll just copy this same formula. So this is equals to Brock's time is D7 plus F7, D7 plus F7, right? This is 14. Similarly, you can have 19, correct? And then you find out the average equals to 5 plus 7 plus 14 plus 19 divided by 4. So this is my turnaround time. Is it understood or not? Is the problem understood? Is the problem understood or not? Anybody having doubt over here?
No, sir.
Okay, so this is being given over here. This is P0 having this time. We have computed the same that I have shown over here is being written, and the average waiting time is computed to be 5.75. Can you solve this one? Another problem. The same process 1, 2, 3, 4, 8, 4, 9, 5 it is given. The execution time is 8, 4, 9, 5. Arrival time is 0, 1, 2, 3 in this order. Who will be executed first? The P1 is executing first. Correct? And do remember, not necessary that always it will be given 0, 1, 2, 3. Maybe 2, 1, 0, 3 like this. Whoever having 0 will be executed first. Then when the next arrival time will be selected. The next arrival time. Suppose I will change it. It may be 2, maybe 0, maybe 1 and 3. Just see over here. Now, if this is there, then everything will change. Everything will change now. Everything will change now. Can you tell me if this is the situation, who will execute first?
P1.
P1. Then P1 will execute for how much time? P1 is for 3. So 0 to 3. Then it is P2. P2 is from 3 to how much? 3 to 11. The third one, it will go for P0. P0 is arrival time 2. So for P0 it is 5. 5 means 11 to 16. Are you getting me or not? P3 is 6. P3 is 6. So 16 to 22. 16 to 22. Can you see the in previous case also the it is from 0 to 22. Here also the 0 to 22. The time is same. It is going from 0 to 22. Correct? Here also it is from 0 to 22, but the order is different. The order is different. Correct? Now what is the waiting time for P0? P0 got at what time? 11. P0 got at 11, but arrival at time at 2.
9.
Yes. So P1
0.
P1 0. Very good. P2 is 3 minus 1.
2.
Yes.
2.
P3 is 16 minus
13.
3. Yes.
13.
Yes. Very good. So now you find out the average and you can compute that what is the average waiting time, right? 9 plus 2 plus 13 divided by 4. You can see last time it was 5 point, now it is 6. Now it is 6. Is it understood or not? And turnaround time similarly we can compute with D6 F6. D6 plus F6, and you can compute in that way, right? 3, 8 plus 2, 10, 19. So you add it, I don't know, is equals to 14 plus 3 plus 10 plus 19 divided by 4. So this is the turnaround time. So this is different from the previous one or not? That means if the order of arrival changes, the the waiting time and turnaround time also changes. So this is being computed over here. I hope this is understood. The P1, P2, and this is the arrival time, and we got similarly it is being solved, and we got the average waiting time. Is that understood? In fast come fast serve, what is there? It simply schedule the job according to their arrival time. According to their arrival time. So we look into this arrival time and we'll put it in the Gantt chart and we'll compute. The job which comes first in the ready queue will get the CPU first. Lesser the arrival time of the job, sooner will the job get the CPU. FCFS scheduling may cause the problem of starvation if the burst time of the first process is the longest among all the. So what is the problem over here? Problem is that if the burst time of the first process is the longest among all the jobs, just think of if the zero time which arriving is, suppose this is 36 or 46, what will happen? All other jobs has to wait. So this problem can you solve or not? This is I am not solving, you will solve of your own. P0 arrival time, P0, P1, P2, P3, their arrival time and burst time are given. You have to compute the waiting time and turnaround time. What is turnaround time? Completion time minus arrival time, or what I have said, burst time plus execution time. Correct. So this is being given over here. The arrival time, burst time is given. So the completion time is this is the completion time is being computed because for each one the average waiting time is being computed with a Gantt chart. So first P0, then P1, then P2, then P3, and their waiting time is being computed, right? So P1 is waiting for 6 and came at 1. So how much time it is waiting? P1 is waiting for 5. P1 is waiting for 5, right? So 8 plus 5, it is 13 is the turnaround time. Are you getting me what I'm saying? So either you go for 8 plus 5, 13, or in the P2 you see P1, you see that it is completing in 14 and therefore 14 minus 1 is 13. So turnaround completion time minus arrival time. This formula also you can use. And similarly we can compute for the others. Just look into the slide and try to understand. If any doubt is there, you ask me, because you will definitely get some problems. This is the simplest problem I am going for. FCFS is the simplest scheduling algorithm. Then we'll go for a little bit more complex other algorithm. This is the first algorithm, is the fast come fast serve. Is it understood or not? Everyone understood this problem?
Yes, sir.
Okay. So now we'll go. What is the problem over here? It says that if a longer job or the longer burst time is there ahead of a shorter job, then the shorter jobs has to wait for a long time, right? Suppose you have a very narrow road in which a very a long vehicle or large vehicle is going over there and there is no space to overtake. Then you have to, even if you have a very high speed bike, you cannot overtake because you cannot cross and go. You have to wait till the slower vehicle has to complete its task. Similarly, when a longer job is there, a higher burst process is executing, the shorter burst processes has to wait. This effect is known as Conway effect. This effect is known as conway effect. To remember, what is conway effect? Conway effect is phenomenon associated with the FCFS algorithm. So this is with what? Only with FCFS, in which whole operating system slows down due to the few slow processes. So if I go for FCFS and a slow process is running, that means all other processes, even if they are faster and shorter, they cannot execute because a slow process is executing fast. And we cannot take it out also because it is a non-preemptive algorithm. Because it is a non-preemptive algorithm, we cannot take the process out during its execution. Is it understood? This effect is known as conway effect. Is it understood? So this is an example. Assume that we have one CPU bound and many IO bound processes. So the CPU intensive process is allocated the CPU time. During time, IO bound processes complete their IO operations. So however, IO bound processes are made wait as the CPU intensive processes. So this makes the IO devices being idle, right? Similarly, in alternative way also, CPU can also sit idle if there are many IO bound processes are there. So hence the conway effect says one slow process slows down the performance of the entire set of processes and leads to wastage of CPU time and other devices. Correct? So what is the solution for this? We can go for preemptive, means while running, if I found a process is very slow, I'll preempt it. So preemptive algorithm I will use instead of using FCFS, I will use preemptive like other algorithms, round robin and other algorithms are that can use. So conway effect occurs in FCFS. So what is the advantages of FCFS? Easy to program, fast come fast serve, simply scheduling algorithm. But what is the disadvantages of FCFS? Because of non-preemptive nature, the problem starvation arises. Starvation arises. Do remember, question will come, which algorithm suffers from starvation? So FCFS may suffer from starvation, right? This FCFS is what kind of algorithm? It's a non-preemptive algorithm. A starvation occurs means even if it is ready to execute, but it is not getting a chance. Starvation means the process is ready to execute, but it could not execute because of because some higher priority process is running or some but another process is running. So process is ready to execute, but at the same time it is not getting the chance. So FCFS has more average waiting time. And all this, it's 11:40. Let me first take the attendance. Otherwise it will be your attendance 2, 3, 4, 5, 6, 7, 2 is 2 permanent absent. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 22, 23, 24, 25, 27, 30, 33, 37, 39, 54,
Sir, 16%. Sir,
cannot hear out.
so 16%.
16 present, okay. 67, 73. Acha, Subhasri Samantara, your roll number? Subhasri, your roll number, Subhasri Samantara.
Sir, 16, sir.
Oh, Tamar, you should come write your roll number over there. Na?
Sorry, sir.
Okay, excuse me. Okay, just calling the absent roll number again. Roll number 2 is absent. 57, I wrote 58, I'm sorry, 57 is present. 57 is present then, okay. Roll number 2, 22, 25, 27, 30, 33, 37, 39, 54, 67, 73. Okay. It's okay. So as it's time, I will end the meeting now. This slide I will, in the next class again I will explain it, then we will go for another kind of algorithm. Correct? So I'll end the meeting now.